For this final video of Chapter 3, I'm going to be talking about concentration. So concentration means when you have some matter dissolved into a liquid. And I'm going to be focusing mostly on molarity. Now, molarity is just a unit of concentration. And at the end of the video, I'll mention a couple other units. But molarity is far and away the most common unit used for concentration in chemistry. So I'm going to focus mostly on this one. So I want to identify a couple terms first. So this is solute, there's solvent, and there's solution. Alright. So when you're mixing two things, the solute is the thing that gets dissolved. So let's say you're making salt water. You dissolve table salt, NaCl, into water. The salt is the thing that's getting dissolved. So the salt is your solute. In that same example, water would be your solvent, because the solvent is the thing that does the dissolving. And water is going to be by far your most commonly seen solvent. It's not the only thing that could be a solvent. Basically, just about any kind of liquid could be. But the vast majority of examples you'll see in this class are going to be using water. And then solution is just the result of mixing the two. So it's the result of dissolution. So when you dissolve something into something else, you end up with a solution. So let me switch it back to black. Alright, so molarity, it's represented by a capital M, and in fact, when you do a calculation, the actual final unit is just a capital M that you use for molarity. And it equals, mathematically, the moles of your solute over liters of the solution. In this case, so most of the time, only your solvent will be a liquid, and if that's the case, then you only need to worry about the volume of your solvent. However, you can have a liquid solute, and since this says liters of solution, if your solute is also a liquid, you would have to add those two volumes together to get the total volume of your solution. Right? So let's say we have, going back to our example of salt water, 1.233 grams of NaCl gets dissolved in 250 milliliters of water. Okay, what is the molarity? Well, we know we need our solute on top, and again, this is solid, so we can just use this one volume, and we need that on bottom. So let's start with the units we have. So right now, we'll just say we have 1.233 grams of NaCl per 250 milliliters of water. Now we need to convert grams to moles. And we need to convert milliliters to liters. And you can do these, so I'm going to do them all together as one line of conversion factors. If you want to do them separately and then put them in a fraction, that's totally fine too. Honestly, however you set up these calculations, as long as you set them up in a correct way, I couldn't care less which way you prefer. So let's do the numerator first. So we need to convert grams to moles. So like we have already numerous times, we're going to use the molar mass. Grams is on top, so we need to put that on bottom to cancel it out. And that leaves us with moles in the numerator, which is what we want, right? So 58.45 grams per 1 mole. That cancels out the units of grams of NaCl. So now we have moles of our solute, which is NaCl, divided by milliliters of our solution. And so this is an example of why you want to remember the metric prefixes that I talk about in Chapter 1. So milli. Milli is basically 1/1000th, which means that there are 1,000 milliliters in 1 liter. So that will be our next conversion factor. Now, milliliter is in the denominator. I think this is our first example, at least that I've done through video, where we have a unit starting in the denominator that we need to cancel out. So, if we need to cancel out milliliters that's in the denominator, we have to put it in the numerator up here, which means liters goes down here. And we said there are 1,000 milliliters in 1 liter. So units of milliliters gets canceled out. And now the only units left uncancelled are moles of our solute, which is what we want, and liters of our solution, which is also what we want. So, like always, we could just multiply all the numerators across, multiply all the denominators across, and then divide. And when we get that, we end up with an answer of 0.08438 molar, it's called, which is just the unit version of molarity. And so that is 4 sig figs, because both of these numbers that we started with have 4 sig figs. And again, you wouldn't use anything in this, this conversion factor or this conversion factor. So that would be the molarity of that solution. Let's do another example. I'll do another example quick. So let's say in this case we're given the molarity. So we have a molarity of 0.250 and a volume of 175 milliliters. And we want to know what the number of moles of our solute is. Then we'll say that this is a solution of NaCl again. So we can set up our calculation. So we've got 0.250 molar equals, so we're looking for X, so moles of NaCl, which is what we're looking for. And remember, we have to convert this to liters. So it's 1,000 milliliters in 1 liter. So you have to basically divide this by 1,000 to convert to liters. So that would be moving the decimal to the left 3 spots. So 0.175 liters. Now, if you have this in the denominator, I've seen a common example, or a common mistake in the past of students where they would just divide both sides by 0.175 to cancel it out here. But 0.175 is starting in the denominator here. If it's in the denominator and you want to, and again, we have to cancel it out from this side because we need to isolate whatever variable we're solving for. We're solving for moles of NaCl, so we need to get that variable by itself on its side of the equation. So if this is in the denominator, we have to multiply by that, so that way we end up with that unit in the numerator, right, and the denominator, and that's how it cancels out. So of course we have to multiply, we have to do the same thing to both sides. So here, these 0.175 liters cancel out, and these are the just moles of NaCl on this side, and we can just do the 0.175 multiplied by 0.25, and that gets us a final answer of 0.0438 moles.